So if perplexity equals to 1, the model perfectly predicts the sequence with 100% accuracy. So basically the model is not at all confused. But if perplexity equals to 10, it can be interpreted that at any given point of time, the model has about 10 options to choose from to put a word in the next sequence. And eventually, the model is very confused because it is having 10 options to choose which word to put in. Hence, it is not able to clearly decide. So, higher the perplexity, more confused the model is. So, how it is calculated? Using this particular equation, this mammoth equation that might be looking very dangerous to you, but I will be trying to demystify it. So assume that we have this particular text given by the LLM. The cat sat on the mat. So basically, assume that you gave some prompt and you got output for this. Do remember that for perplexity, you don't need to have any ground truth. So the step one would be calculating the probability of each word given the previous word. So the first word is the, assume the probability to be 0.5. Cat given the, so cat is the next word. So probability of cat given the previous words. Probability of sat given the previous word, that is the cat. So if you see sat, the cat, on, the cat sat, the cat sat on. So we are calculating the probability of the next word coming into the sequence given the previous words. Assume we calculated all these probabilities, apply log and add these probabilities together. So you need to apply log on the individual probabilities that we have calculated, that we have got from the model basically, and then eventually apply log and add them, and then apply exponential dividing it by the total number of words in a sentence. Very easy. Assume the value comes out to be 2.275. Hence, perplexity is 2.275, meaning the model needs to choose between about 2.275 words for choosing the next word in the sequence. For calculating perplexity, I think you must have understood by now, you need to have probabilities of prediction available with you. Basically, perplexity can't be calculated using APIs because APIs are directly giving you the output, not without the probabilities. So basically, if you're using a local LLM, if you're using Hugging Face models, I think you should be able to get the probabilities and eventually you can calculate perplexity. Else, you have the model. There's a package called as Evaluate, which provides this metric to be calculated by Hugging Face. Next up, we will be calculating the BLEU score. BLEU score is again a very important and popular metric in this particular field of text generation and NLP. So BLEU score stands for bilingual evaluation under study, and again, it has a very scary looking equation: b into exponential summation weight I into log pi. It does require a ground truth, so do remember that. In this particular equation, BP is brevity penalty, weight I is weight assigned to each to precision of each n-gram, and PI equals to precision of each n-gram. So I will be telling you everything. Don't worry. Again, let's assume an example. Assume this is the ground truth. The cat is on the mat, and the candidate sentence, that is a generated sentence by the LLM, is the cat sat on the mat. The first step is to calculate n-gram precision. So by assume n equals to 2. So that is 2 gram precision we are calculating in this example. This can be 3, this can be 4. So if we are selecting n equals to 2, we need to calculate precision at 1 gram and 2 gram. If n equals to 3, 1 to 3 grams. If it is 4, we need to calculate precision for 1 gram, 2 gram, 3 gram, 4 gram, etc. Now we will be understanding how to calculate the n-gram precision, starting off with 1 gram precision. So basically, it is a unigram precision that we will be calculating. These are the individual tokens present in the ground truth, and these are the individual tokens present in the generated text. Now, the exact matches are 5 tokens. So out of 6 tokens, 5 tokens have been matched. So the 1 gram precision is number of matches, that is 5 total unigrams in generated text. Generated text is 6 words, so 5 upon 6. Similarly, if you go to 2 gram precision, 2 gram is basically the pair of words that are simultaneously coming. The cat is on the mat. The cat sat on the mat. So eventually, if you look here, the matching bigrams that we have got, 2 grams, is the cat on the mat from the reference text. So whatever bigrams that are matching, we are calculating that number. 3 matches have been found out of total bigrams is generated. So if you calculate this, the total number of bigrams generated is 5. So 3 upon 5, the 2 gram precision is 0.6. The second step is to calculate the brevity penalty. So brevity penalty is basically used to penalize short candidate sentences. So basically, if you understand, BLEU promotes longer outputs. If the output is shorter than the actual ground truth, it gets penalized. If the length of the candidate sentence is equal to or greater than the reference length, reference basically is the ground truth, brevity penalty is 1, else brevity penalty is exponential 1 minus reference length upon candidate length. Again, it's all mathematics. If the candidate length is less than reference, in the case that we have considered, the length of both the sentences is same, that is 6 words, so eventually brevity penalty is 1. Now finally, we would be talking about the weights. So basically, weights are usually assigned to different n-grams that we are calculating, n-gram precision. So it might be the case that you wish to give higher weightage to bigger gram. So like 3 gram precision might be having higher weightage as compared to 1 gram. That is why weights are assigned. Usually, weights are kept equal for all the n-grams. Assume we are keeping zero point 0.5 as the weight for each of the n-gram precision that we are calculating. So do remember that weight should equal up to 1. So in this case, the final equation, the final BLEU score that we get is 1 into exponential zero point 0.5 into log 1 of 5.6 plus zero point 0.5 into log zero point 0.6, 0.86. This is how BLEU score is calculated. We will be now talking about the rogue score. So rogue score is again very similar to BLEU and Perplexity, a very popular metric which is usually used for benchmarking of LLMs as well. Like BLEU score, it also requires a ground truth, and rogue score is nothing but rogue recall, rogue precision, rogue F1. So we will be calculating three different metrics within this, and we can consider any one of them as a rogue score. Now, Rogue Score has different variants also, and in this particular tutorial, we will be talking about all the variants. So, these are the top variants: Rogue N, Rogue L, Rogue W, Rogue S, Rogue SU. So, let's talk about them using an example so that it is more clear to you. Assuming this is the case, we have got ground truth is the cat sat on the mat, and the predicted truth is the cat lay on the mat. So, there is a change of one word. Rogue N. So, Rogue N is nothing but matching of unigrams. It is very similar to the first step of BLEU that we did. So out of the six tokens that we have got for reference and generated text, the overlap is of 5 words. Hence, precision is equals to 5.6. Recall is equals to 5.6. Do remember that recall is the denominator is total reference unigram. Reference is ground truth. While for precision, the denominator is total generated. That is the predicted unigrams. Do remember this. And F1 score is 5/6 because you are taking the harmonic mean as we do in the case of normal statistics. So rogue 1 is easy. Rogue 2 is also similar to what we did in n-gram precision. Rogue 1 and rogue 2 can be taken as n-gram precisions only, and that we did in BLEU. So we would be first forming out bigrams. Bigrams are nothing but pair of consecutive words. So the cat sat on the similarly, and then we will be checking for overlaps, which bigrams from the generated text are matching with the reference one. So we have got three matching text, the cat on the mat. Hence, precision is 3 upon 5, recall is 3 upon 5, F1 is 3 upon 5. 5 is the total number of bigrams that were generated from from the generated text, while in case of recall, the denominator is coming from total number of bigrams in the generated text. Do remember this. Now talking about rogue L. So rogue L has a little difference. Rogue L basically calculates the longest common subsequence. So longest common subsequence is a very interesting problem in computer science and mathematics, which basically asks you to calculate the sequence that appears in the same order but not necessarily consecutively. So basically, if in the example you say the cat sat on the mat, the cat lay on the mat. So here you can see that if you remove the third word from both the cases, the cat on the mat, the cat on the mat. So the sequence is coming in the same order but it is not consecutive. That is called as the longest common subsequence. So we would be first of all calculating the longest common subsequence length, that is 5 in this case, the cat on the mat. Precision recall F1 score would be calculated similarly, LCS length upon generated text length, recall LCS length upon reference text length. Moving on to rogue S. So rogue S is again an extension towards rogue 1 and rogue 2 that we did. Measures the overlap of skip bigrams between generated text and reference length. So I think in the first case we understood what are bigrams. An update to it is the skip bigrams. So in case of bigrams, we were just considering pairs from consecutive words: the cat, cat, the cat set, etc. In case of skip bigrams, we would be pairing up all the words from all the other words in the sentences, but in the same order: the cat, the sat, the on, the mat. So eventually, we are picking up the first word and pairing it with all the remaining words. Then we will be picking up the second word. Then we'll be pairing with the forward coming words. In this way, we will be forming out skip bigrams. So these are all the skip diagrams that we got from the reference, and these are all the skip diagrams that we got from the generated text. I hope the concept of skip diagrams is clear. Now these are the overlapping skip diagrams that we got, and similarly precision recall and F1 is calculated. Now coming to Rogue SU. So it is an extension of Rogue S that includes both skip diagrams as well as unigrams. So in this case, you saw that there was no unigram considered, but in case of Rogue SU, uh, even unigrams would also be considered. This is done because there is a loophole in S. So Rogue S focuses on pair of words that appear in both generated and reference text. If no such pair exists, Rogue S would be zero. But eventually, assume this particular case that was mentioned in the paper itself. The police killed the gunman, gunman the killed police. Basically, the second sentence that we have generated, it is a reverse of the first sentence. But the rogue S would be zero in the case of the second sentence because it is reverse, and eventually the pairing that we would be forming won't be overlapping with anything because the sequence has been changed. But if you think, would rogue s equals to 0 for the second sentence make sense? It is rogue s equals to 0 implies it is as good as any random sentence like a burger. Now it is not that bad. The words are matching but not in the right sequence. Hence, once you start considering the unigrams also, the recall precision and F1 score for rogue SU would be greater than 0, and hence that is the whole idea. If the sequence is completely distorted in some version, still you get some value if the words are correct. Coming to rogue W, rogue weighted longest common subsequence. This is a little tricky where instead of using the longest common subsequence, we would be calculating weighted longest common subsequence. So in case of a weighted longest common subsequence, what we do, we would be rewarding. So we would be calculating the value of the weighted WLCS depending upon the most consecutiveness within the longest common subsequence. Try to understand this. Assume that this is the reference text ABCDEFG. This is the generated text ABCDHIK, and the third text, the other reference text is other generated text is AHBKCID. Now, if you look closely, the LCS length for the Y1 and Y2 is same, that is 4, because ABCD is going in the same for sequence as in the reference. Here A, B, C, and D is in the same sequence, uh, skipping the consecutiveness. But if you look into the generated result, I think any day y1 is better because the length of the consecutiveness is better. It has more consecutive matches. So rogue w improves this by assigning higher weights to longer consecutive matches. So any match, like basically any overlap that we get in the generated text which has a longer consecutive match in the longest common subsequence is given higher weightage. Now, consider this particular case for y1, the entire sequence is matching, hence consecutive 4 matches. Eventually, weighted LCS would be not 4, it would be function in taking 4 as a value. What function I will be talking about that. Similarly, for y2, the matches are ABCD, but they are not consecutive. Each letter is separated, hence 4 subparts of length equals to 1. So basically, we are trying to figure out subparts within the longest common subsequence, and then depending upon the length of these subparts, we are assigning weights. Now instead of f4, we would be having 4 functions here: f1 plus f1 plus f1 plus s1, because we are having 4 subparts within this longest common subsequence, where f is a weight assignment function. Now this weight assignment function can be anything, it is of your choice, such that fx plus y should be greater than fx plus fy. Why? Just see this. As we wish to assign higher weight to cases where the sub part has more consecutive matches, f4 should be greater than f1 plus f1 plus f1 plus f1. This is the case. Y plus x plus y equals to 4, fx plus fy. If f of x equals to x square, y1 weighted would be 4 square equals to 16, while the weighted LCS for y2 would be 1 square plus 1 square plus 1 square plus 1 square equals to 4. Just remember this. We are not considering the length directly, but the function passing the length as a parameter, and this function is x square. So as the longest subpart consecutive match was 4 of length 4 in case of y1, all ABCD was in subsequence. So the function uses f of 4, that is 4 square, that is 16. Now row W recall would be f inverse weighted LCS of x comma y1 upon length of x, while precision would be f inverse weighted LCS x comma y1 length of y1. This is the equation that we are following now. Similarly for y2 also you can calculate, where f inverse is basically inverse of the weighted function that you're using, that would be root x in this particular example. This function can be anything. Don't think it has just to be x square. The equation is very similar to what we have been following for recall and precision, but just the addition of f inverse in the starting. Now we will be talking about a very interesting metric for LLM evaluation, that is the mean reciprocal rank MRR, which checks how good the LLM is putting the right answer near the top of the list. Basically, you can take it as ranking, a good metric for classification or retrieval task. The metric is quite easy to understand. Assume you are inputting what's the capital of France, and the LLM answers in this sequence: London, Paris, and Berlin. Now, eventually, the answer is Paris, which is at the second position. To calculate the reciprocal rank, reciprocal rank equals to 1 upon position of the correct answer, that is 1 upon 2, because Paris is present at the second position in the answer. Now you would be repeating the same. We will be calculating the reciprocal rank for multiple questions and then averaging the different ranks that you are getting. That would be called as MRR. Very easy to understand. Now, if the assistant often gets the right answer on the top spot, eventually that would be 1 upon 1. Hence, reciprocal rank would equal to 1 for most of the cases. The MRR would be higher, close to 1. If it is not good at it, the MRR would be close to 0. It is as easy as that. Now coming to BERT score. BERT score is also a very important metric used for LLM evaluation and a little tricky to calculate, a little lengthy to calculate. So in this case, we would be using BERT embeddings to calculate the metric to evaluate the LLM predictions. So first of all, what we would be doing, we would be tokenizing the generated text and the reference text, that is the ground truth. It will be tokenizing into subword units using word piece from BERT. I think word piece you must be knowing the tokenizer used for BERT, and converting into token IDs which BERT understands. So basically we need to feed these words into BERT, that whatever has been generated and what is the ground truth, to generate some BERT embeddings as told. So the first step is to generate BERT embeddings. After that, we would be calculating the cosine similarity between the embeddings of generated and reference text, and then we will be forming a similarity matrix. I will be showing you everything, so don't worry. Once you have found out the similarity matrix, we have formed that using best matching. We will be using some greedy algorithm to find the best matching between the tokens in the generated text and the tokens in the reference text. So every word in the generated text need to find the best match from the reference text. That is the whole idea. The goal is to maximize the overall similarity score, and then optimal matching would be done. The algorithm will ensure that the each token that has generated matches with at most one token in the reference and vice versa. So yeah, a matching can't be with more than a single element from the other text. Then precision recall and F1 score would be calculated. That would be called as BERT precision, BERT recall, and BERT F1. Now let's understand this everything with using an example. So assume we have got the same example, similar example with a little twist. The cat sat on the mat. The cat was sitting on the mat. So first of all, tokenization that we would be doing, as you can see, we have already tokenized it. Secondary, we would be generating the embeddings using the BERT model. Third, we would be calculating the similarity matrix using the cosine similarity between each token embedding. So we would be calculating the cosine similarity between and all the tokens from reference, then cat, then all the tokens from the reference, and we will be forming a similarity matrix like this. Here you can see that all the different values that are present are cosine similarity. So the cosine similarity between sitting and the is zero point 0.3. It is just a reference. Get the best matching pairs from reference and generated text. The cat was sat, sitting sat. So basically, you don't need to do anything. You need to figure out which value has the highest cosine similarity for a, and once you form a pair, eventually that one can't be used with other sentences. So eventually, you need to figure out pairs such that the similarity matrix for the overall scenario increases. Now, once all these pairs have been formed optimally using some algorithm, we would be calculating BERT precision, that is the average similarity token, average similarity for tokens in generated text. We are doing just the average of the similarity, cosine similarity, nothing else. BERT recall and BERT F1. BERT F1 would be using precision into recall. So basically, we would these pairs that we are considering, we would be getting the cosine similarity between these pairs, adding them together, and then for precision, we would be dividing it by the length of the generated text, the summation of all the cosine similarity for the formed pairs. For recall, we would be dividing the summation by the length of the reference text, and BERT F1 is easy to calculate, very similar to the one that we use in statistics. So this is how these are the five metrics that we discussed: BLEU, ROUGE score, Perplexity, MRR, BERTScore for evaluating LLMs in this particular tutorial alongside examples. I hope this tutorial was useful for you and you would be able to evaluate LLMs now onwards. Thank you.